Space in general is not a nice place to be. Everything that happens in the universe is simply the result of the blind action of fundamental laws of physics, and the results tend to be overwhelmingly unpleasant to humans, and probably nearly all other living organisms except for certain extremophiles under certain conditions, but even they have tolerance limits. Alexei Leonov was the first human to exit a space capsule to perform a spacewalk. His pressurized suit expanded so much that he almost couldn't get back into his Voskhod 2 capsule. Then there was Vladimir Komarov, who roasted during re-entry in a disaster-plagued Soyuz mission in 1967. These two examples emphasize that reality is unforgiving. If you are alive, there are many more ways for you to die than to stay alive, even here on Earth. And you will, of course, inevitably die anyway. But let's talk about space travel, and about a few places or conditions you may want to leave off the list of your next interplanetary and interstellar vacation adventure. Let's begin. In our solar system. This is a fairly easy one, because we already know from direct exploration that almost every location in our solar system will kill you instantly, except for certain parts of Earth, and even that's really just a matter of time. So, we'll be a bit selective here. If you would like to die by several different methods virtually simultaneously, Venus would be a good choice. Venus is sometimes referred to as Earth's very nasty sister planet. It's the second planet from the Sun, and nearly the same size and mass as Earth. And so, if Earth is inhabited, Venus should be as well. Except something went horribly wrong, and it's the so-called greenhouse effect. It looks pretty from a distance, but Venus will roast and fry and inseminate you instantly, because its surface temperature is well over 800 degrees Fahrenheit. It will also instantaneously crush you, because atmospheric pressure at the surface is about 92 times that of Earth. On top of that, it will also instantaneously suffocate you, since its atmosphere is almost entirely carbon dioxide, with trace amounts of nitrogen, and upper atmospheric clouds of sulfuric acid. The former Soviet Union launched 16 Venera probes to Venus, 10 of which landed successfully, and all of which were melted or crushed in periods of time, ranging from 23 minutes to about 2 hours. But much of what we know about Venus is owed to this Soviet program. Why this set of conditions exists has attracted a lot of attention, and the current explanations are fairly complex. Briefly, one consideration is that stars expand as they age, and early in the history of our own system, our Sun was smaller, and Venus was well within what is called the habitable zone. There was certainly abundant water on Venus at the time, because water is just about everywhere else in our star system. But as the Sun expanded and bodies of water vaporized, water vapor accumulated in the Venusian atmosphere, which created a heat trap. More importantly, carbon dioxide on Venus doesn't seem to be absorbed by the crust or lithosphere and turned into carbonates, because of the lack of the recycling of plate tectonics. And so it all ends up in the atmosphere, where it acts as a greenhouse gas. CO2 is also a greenhouse gas on Earth, even with our plate tectonics, because we are generating CO2 faster than it can be reabsorbed. Finally, it has been recently discovered that Venus actually has active volcanism, which means that at least the sulfur dioxide in the upper atmosphere and certainly many other gases are being replenished. Mars is another place that people seem eager to go to, but it will also kill you. The good news is that it is in theory possible to protect yourself there, although in practice, we don't really yet know how to do this. Mars is not as dry as we once thought, at least below the surface, but it's still extremely arid by Earth's standards. There is of course the radiation as a result of the absence of a deflecting magnetic sphere shield, but there is also the deep space radiation problem that has to be solved long before humans ever reach Mars, or they'll all be corpses long before they get there. Then there's the low atmospheric pressure, about 1/100th that of Earth, due to the weak gravitational field. The lack of a magnetosphere allows radiation to split atmospheric molecules, which are heavier, into constituent atoms, which are much lighter and therefore have a much lower escape velocity. If you are somehow unprotected on the Martian surface, the result of this low atmospheric pressure, according to Pascal Lee of the Ames Research Center and SETI, is that your blood would fizz like a newly opened bottle of carbonated water, and this would kill you in seconds. Earth's atmosphere is mostly nitrogen, about 78% and 21% oxygen. Mars's atmosphere is almost entirely carbon dioxide, with almost no free oxygen. Anyone who goes to Mars will obviously have an ample supply of oxygen, and there are experimental technologies to create oxygen from the apparently abundant water near the Martian surface. But the fact remains that Mars will suffocate you unless you have a steady supply of oxygen. Unlike Venus, these considerations, along with the temperature and surface radiation, are problems that can be managed, although the technologies required are no small considerations. Venus cannot be managed, but Mars may be, and we will eventually find out. There are many and much more extreme planets and moons in our system, places we have no hope of ever sending a human to any time in our lifetimes. And then there are exoplanets, planets that are part of other star systems. We can't of course directly examine any of their characteristics, and in almost all cases can't even spectrographically analyze their atmospheres, but we can indirectly calculate their likely compositions and temperatures. Many of them may possibly be relatively pleasant, although this doesn't mean we could survive on them. But out of these exoplanets, where would be even worse? Well, there are a lot of them. Here are a few, and things get really rough. OGLE 2005 BLG 390LB. Referred to by Star Wars fans at NASA as Hoth, this super-Earth in the OGLE 2005 BLG 3901 star system, about 21,500 light-years away, is probably rocky, hence classified as Earth-like, and about 5.5 times as massive, and most likely has a thin atmosphere. The host star is probably a cool red dwarf, or possibly a white dwarf, and the planet orbits at a distance from its host star at anywhere from 186 million to 372 million miles. We of course have no idea what the planet actually looks like, but we can infer that with its host star as a red dwarf, and the distance between Hoth and its star, it is extremely cold there, because the temperature on the surface is probably about minus 369.4 degrees Fahrenheit. Pluto is actually colder, but this wouldn't matter to you if you were in either place, as you would shatter into tiny pieces in seconds. Calt 9b. On the opposite end of the temperature spectrum is Calt 9b, aka H9195689b. Discovered only in 2017 by two telescopes, one in South Africa and one in the US state of Arizona. It is an extremely hot gas giant, a hot or ultra-hot Jupiter. It's about twice the diameter and 3 times the mass of Jupiter, about 670 light-years from Earth, in the constellation Cygnus, and there are some extremely unusual things about it. First, it is tidally locked around its host star, which is twice as hot as our own Sun and 2.5 times more massive. This means it only presents one hemisphere towards the star. Second, its year, or orbit around its star, is equal to 36 hours in Earth terms, or about 1.5 Earth days. Third, it is in a polar orbit, which means that it actually orbits its host star around the star's poles rather than its equator. Fourth, it has an average temperature of 7,800 degrees Fahrenheit, which is hot enough to actually melt molecules in its atmosphere, which can only recombine after the atoms circulated through the atmosphere to its dark side. The fact that it even has an atmosphere is odd. NASA's Spitzer telescope showed that molecular hydrogen shreds into atomic hydrogen on Calt 9's bright side, and then recombines on its dark side, only to repeat the process again and again. There are some other known hot Jupiters that are hot enough for this to happen, but so far it's only been detected on Calt 9b. but it's safe to say this is a good vacation destination if you hate winter. HD 189733b. This planet, discovered in 2005, is a Jupiter-sized planet 65.5 light-years away, with a rather pleasant and inviting blue tint. The star, H9 189733, is located in the constellation of Vulpecula. Since no one has ever seen it, there are all sorts of ways to envision it, and people have. Since it's so close, there has been significant and ongoing studies of its atmosphere, which appears to be rich in water vapor, oxygen, methane, sodium, potassium, carbon dioxide, and silicates, and this latter is actually what gives the planet its blue color. There are a few things that make this planet extremely uninviting, regardless of how pretty it looks though. First, as expected, it is tidally locked with its star, HD 189733, and the temperature differential between the near and far sides creates winds of unimaginable velocities, up to 5,400 miles per hour, which is 7 times the speed of sound. Second, temperatures on the side that face the star can reach 1,700 degrees Fahrenheit. Thirdly, the winds carry a rain of molten glass, which doesn't actually fall, but rather ravels sideways. This molten silica is what gives the planet its blue color, rather than oceans, which gives our own blue marble its color. Venus rains sulfuric acid, Neptune rains diamonds, WASP 76b, the next on our list rains molten iron, and HD 189733b rains molten glass. This is some pretty nasty weather. WASP 76b. WASP 76b is a gas giant with a mass about 92% that of Jupiter, in the WASP 76 planetary system, about 640 light-years away from us. It orbits so close to its star, WASP 76, at 0.033 astronomical units, that its year lasts only 73 hours, and it's certainly tidally locked, so that one hemisphere is always facing WASP 76, and one is always in shadow. WASP 76b is so close to its star that it's essentially within the star's outer atmosphere. Visiting any place named WASP doesn't sound terribly appealing, but the name just comes from the UK-led WASP telescope system, or the wide-angle search for planets. WASP exoplanets are special for us right now because the wide-angle search for planets is ground-based, compared to the Kepler exoplanets, which are much further away and fainter. WASP exoplanets are close enough and orbiting stars bright enough so that we can get follow-up detailed studies. And this is why we know what we do about WASP 76b, and it's not a nice place. For one thing, its day side is greater than 4,535 degrees Fahrenheit, or 2,400 degrees Celsius, which is hot enough to atomize iron and zinc. The shadowed hemisphere is almost 2,000 degrees Fahrenheit cooler, which certainly creates ferocious winds of vaporized material. Spectroscopic observations by the Espresso instrument, part of the Southern European Very Large Telescope in Chile, indicates that at the frontier or terminator of the day and night sides, there seems to be an atmosphere of iron vapor that then condenses on the night side into a rain of molten iron. Something similar seems to be happening on OGLE TR56b, which seems to have clouds of vaporized iron, and COROT7b, which apparently rains re-solidified molten rock in the form of pebbles. But you wouldn't have to worry about that, because either on the dark side or the light hemispheres, the temperatures would kill you instantaneously. And on the day side, you would of course be vaporized, and on the night side, you would be immediately reduced to ashes by molten iron rain. So in conclusion, it's certain that there are probably an infinite large number of places in the universe that will kill you in infinitely unimaginable ways, largely due to temperature and atmospheric composition. These are just 5 of many thousands of planets that we know of. Without an FTL or faster than light method of travel, we will never visit any of these, and so we will always be reliant on steadily improving observational technology to tell us whether we will ever know about any of these places. There is an infinitely large number of things we will never know about our galaxy and the universe as a whole. So that's it for this video. We hope you've enjoyed, and we'll see you next time for another one.